In today's lecture, we are going to discuss the pixel relationship. The pixels may have the horizontal neighbors, pixels may have vertical neighbors. We will discuss the N4P set, N8P set and ND. D stands for diagonal set. In the next topic, we will have the adjacency relationship between the pixels. So first we will take an example of pixel set in arrangement of 3x3 image. So this is called the central pixel, and the central pixels may have two vertical pixels and two horizontal pixels. And when we combine all these four, it becomes the N4P set. This is called the N4P. These are the neighbor of this P. If we calculate or compute the coordinates of this pixel, we can arrange this in order of, suppose this is my central pixel which is having the coordinate x comma y. Then the other pixels may have the coordinate like this. This will be x plus 1, this is x, x minus 1, y plus 1 and y minus 1. So accordingly we can calculate or compute the coordinate of each pixels. In addition to this, these four pixels which are the diagonal to the central pixel P, which is the red color, these are called as its diagonal pixels, and this set of pixels is known as NDP. When we include all these 8 pixels, then we compute a new set P, that is N8P. That means the pixel P is having 8 neighbors which is having horizontal pixels and vertical pixels. The next we will discuss the adjacency. So before discussing the adjacency of pixels, we have to study a set intensity value set V. Intensity value set V. The intensity value for the binary image may be 0 and 1, but for gray images the labels may be vary from 0 to 255. So when we discuss the adjacency, we have to take care of the intensity value set V, which may be the combination of any value ranging from 0 to 255. So in case of adjacency, we have the three types of adjacency. First is 4 adjacency, second is 8 adjacency, and third is the mixed adjacency. So we take an example. So what is 4 adjacency? So the definition for the 4 adjacency is if 2 pixels are said to be 2 pixels P and Q are said to be 4 adjacent if Q belongs to N4P. That means if Q lies within the range of the 4 neighbors of P, then P and Q will be set to the 4 adjacent. For example, the V set is given is 1, 2, 3, and a pixel arrangement is like this. And I want to check whether pixel P and pixel Q are 4 adjacent or not. So we can see the pixel Q is not lying within the N4P, because the N4P are this pixel, this pixel, this pixel and this pixel. So the P and Q are not having the 4 adjacency. But if we talk about the pixel arrangement of Q, so we can see that now 3 is in the N4P of Q is in the N4P. So, and this value is also within the set V. Then we can say that pixel P and Q are 4 adjacent. Similarly, we can compute or we can discuss the 8 adjacency. So the definition of the 8 adjacency is two pixels P and Q are said to be 8 adjacent if Q belongs to N8P. So N8P, so again we take an example of 3 cross 3 pixel arrangement, and this is having value suppose 4 5 3 2 1 1 3 2 1, and the given value set is 1 2 3. And now my question is whether two pixels, suppose this is my P and this is my Q, are 8 adjacent or not. So what we will see, first we will check whether this Q belongs to N8P. Yes, it belongs to N8P. Second condition, we will check whether this Q belongs to the given set V. No. So P and Q are not 8 adjacent in this case. But suppose I change my pixel Q here, then first I check whether this Q is lying within the N8P. Yes. Second condition, I will check whether this Q is also belonging to the given intensity value set V. Yes. So in this case, P and Q becomes the 8 adjacency. The problem with the 8 adjacency is that it may create the multiple paths. So we have introduced a new adjacency relationship, that is the mixed adjacency. So this is represented as M adjacency. So here two pixels P and Q are said to be M adjacent if Q belongs to, condition number 1, Q belongs to N4P. That means if Q is in the region of 4 neighbor pixels, then it will be having the mixed adjacency also. Or second condition is Q belongs to NDP and N4P intersection N4Q should be equals to 5. The meaning of this is, if this condition is not true, we can check this condition also, that the Q pixel is lying within the diagonal of P and there should be no common pixel of N4P and N4Q. Let's take an example. Suppose we have a pixel arrangement like this. And the given value set V equals to 1, 2, 3. And I am interested to find out the relation between the pixel set P and suppose this is Q, and I want to check whether this is M adjacent or not. So what I will check first, whether the P or Q, whether the Q belongs to N4P. So this does not belong to N4P. So first condition is false. So I will go for the second condition, whether the Q belongs to NDP. Yes, Q belongs to NDP. Second condition with the NDP is whether the Q belongs to also given set V. No. So this condition also false. This condition also false. It implies that pixel P and Q are not M adjacent. Similarly, if we check for the another pixel Q here, again we check whether Q belongs to N4P. No, Q does not belongs to N4P. But if we check Q belongs to NDP. Q belongs to NDP. It is okay. Next condition we will check whether Q belongs to the given set V. Yes, it belongs to the given set V. That means in addition to this condition we have to check also N4P intersection N4Q equals to phi. So what will be the N4P here? This is my N4P, this is my N4P, this is in my N4P, and this is my N4P. Next, what is the N4Q? This is my N4Q, this is my N4Q, this is my N4Q. It should be equals to phi. So what we see here, that this pixel is common in N4P and N4Q, and this is also belonging to the given set V. That means this pixel P and Q cannot be the M adjacent in this case also. So we can take another example. Suppose my Q is here. Again I check the N4P and N4Q. This is my N4P, and N4Q becomes like this, this, and this. So what we see here, that again there is no common pixel. There is no common pixel among the N4P and N4Q. If there is no common pixel, then we can say that pixel P and Q are M adjacent. So in this way we can find the adjacency relationship between two pixels. Okay.